This lesson is about the rules of probability. So I have two definitions for you before we get started. The first one, the sample space, is the set of all possible outcomes. And I'll give you an example of that in just a second. The next one, the probability model, is going to include two things. First thing, it will include the sample space. The second thing is that it includes the probability of each outcome. So for example number 1, I imagine that I'm flipping a fair coin 3 times. I am going to give a probability model for this process. There are several ways that you can think about all the possible things that can happen when you're flipping a coin. One thing you might have done in the past is you might have done like a tree diagram or something. If you would like to use that, that's fine. If you feel like you can get all the outcomes just in your head, that's okay too. So here's a list of all of our outcomes. Usually when we write our sample space, it's actually written in brackets like this. Sometimes it'll be written as like S equals, for S for sample space. So each of these is one possible outcome. And the first one would be heads 3 times. The second one would be heads the first flip, heads the second flip, and tails the third time. So you can see what all of these are. And because the coin is fair, actually our probability for all outcomes is going to be 1/8 because there's 8 outcomes. So the probability for all outcomes is 1/8. So I'm actually going to show you another way that you often see the probability model written. You won't see it, well, you'll see it a few times in this chapter. You won't have to write it out like this every time, but you might be asked to do it, and you'll definitely see things that are written like this, so I'll show that this way to you. So you'll often see it written as like you'll have outcome in one column and the probability in the other. So for this case, there are actually several outcomes that I can combine. And so for example, the first thing, I can have 3 heads and 0 tails. That happens in one place, which is the one I just circled. And so that one has a probability of 1/8. The second possibility is I could have 2 heads and 1 tails. And you'll notice that that happens in several different places. So that happens in 3 places. So you have a 3/8 probability of getting that. Another possibility is getting 1 head and 2 tails. That happens in 3 different places again. So it's 3/8. And your final possibility is getting 0 heads and 3 tails. And you'll notice that happens in one place, which means it's going to be a 1/8 probability. So this is just another way of writing a probability model. And this actually will probably be the one that you see the most often. So here are my rules. So for number 1, the probability of any event is a number between 0 and 1. Sometimes you think of 1 as being like a 100% chance of things happening. And the second important thing is that all possible outcomes must have probabilities that add up to 1. So if you look back at the previous slide, you'll notice that all of our probabilities added up to 1, no matter how we wrote our probability model. In both ways, they added up to 1. So the probability that an event does not occur is going to be 1 minus the probability that it does occur. I'm going to actually write that kind of below this because I have another way of writing it. And you'll often see an event written as a letter like A or B or something like that, I'm going to call this A. So the probability that A does not occur, you get by subtracting 1 minus the probability that it does. And the probability that it does occur, I wrote as P of A. So you'll see that written more often. And the probability something doesn't occur, we are going to call this the complement. So another important thing is that if two events have no outcomes in common, we say that they are mutually exclusive. And I'll give you an example in just a minute where things are mutually exclusive. Sometimes you'll see it also called disjoint. Those are both different words for the same thing. So let's say you have two events, and I'm going to call them A and B. And in this case, when they're mutually exclusive, the probability that one or the other occurs is the sum of their probabilities. And this is true when it's mutually exclusive. When they're not mutually exclusive, which I'll talk about later, we have another formula that we're going to use. So for example 2, you can see an example of a probability model, and this is for students who took the 2013 AP Statistics exam. Before we do the problem, I do want to mention that these 5 possible events, there's 5 possible events, all the scores are mutually exclusive. So I'm just going to write it as ME. So the scores are mutually exclusive. The reason is that you can't get 2 different scores. You can't get a 2 and a 3 or a 3 and a 5. You can only get one of them. So we call that mutually exclusive. Because they're mutually exclusive, that allows us to use the formula that I have up here. I'm allowed to just add the probabilities together. So the first thing I'm going to do is I'm going to show that this is a legitimate probability model. And we have an important rule up at number 2. The important rule is that all possible outcomes must have probabilities that add up to 1. Oftentimes, this is a very common multiple choice question where they'll give you 5 different models, and they'll ask you which one is wrong or which one is right. You can find that by adding them all up and seeing which one adds up to 1. So you show it's a legitimate probability model by adding them all up. And once you know what to do on this one, it's actually very easy. If you don't know what to do, of course, it's not easy. But all you're going to do, you can even use your calculator, is you're going to add all these up. And you will find that if you check these out, you will get 1. So we're good. You can even put a smiley face if you want to. So that's the first thing. The second thing is a very, it's a very common type of thing that you'll be asked to do. So you're going to look for the probability that the chosen student scored 3 or better. We're going to assume that you choose any student at random, and we want to know the probability that they scored a 3 or better. So I am going to look at these 3 parts right here. And the way that I am going to write it out is I'm going to write it out as probability of 3 or better. Sometimes you'll see things written as like probability of A or B, but my 3 or better is the event I'm looking for. So 3, 4, 5, and also 1, 2, like I said, they're mutually exclusive. You can't get more than 1, so we are allowed to add them. So we're just going to add the 3 probabilities for 3, 4, and 5. And when you do that, you find that the probability is 0.577. And that's my answer. For example number 3, this actually most likely will probably look very familiar. You've done stuff like this before when we were first talking about quantitative data. You've seen these two-way tables. This is going to be exactly the same, just a different way of asking the question. So we want to find the relationship between educational achievement and home ownership. They tell us that a random sample of 500 adults was selected, and they identified them as a high school graduate or not a high school graduate, and a homeowner or not. So we have two events here. The first event is the high school graduate. I'm going to refer to that as G. The second event is being a homeowner. I'm going to refer to that as H. So now for this example, we are going to choose a member of the sample at random. We want to find the probability that the member is a high school graduate. So I'm going to write that as P of G. That is a way to write probability of being a graduate. So this one actually is not a hard problem. We're looking for the total sample, so the denominator is going to be 500, and out of the total sample, there are 310 people who graduated high school, and that's actually my answer. If you really, really want to, you can write that as 0.62. I don't really care how you write it. Some people even prefer 62%. All three answers are fine, but you'll find oftentimes it's a little bit easier to actually keep them as fractions because you might have to add them up later on. One more thing is if you're taking the AP test and you only write 0.62, there's a very good chance they will mark you off because you didn't show work. So at the very least, put your fraction in. So then for part B, we want to know the probability that a randomly selected person is a high school graduate and owns a home. That is going to be this 221 right here. And I'm going to write that as probability of G and H. And you'll find that that's going to just be 221 out of 500 because we're looking at our entire sample. Once again, you can feel free to write that as 0.442, but 221 over 500 is also fine. So the third type of problem is a little bit more interesting. So they ask you to find the probability that the person they chose is a high school graduate or owns a home. So for this one, there are several possibilities. So there's these 221 people who are high school graduates and own a home. There are these 89 people who are not high school graduates or are not homeowners, but they graduated high school, so they're still counted. There's also these 119 people here who own homes, even though they didn't graduate high school. So actually, we need to add up all of those. So I'm going to write this as probability of H or G. And you are going to add up all of those probabilities. You'll find in the end that it is going to be 429 over 500. Or if you like it as a decimal, you can write it as 0.858. So I'm going to give you what we call the general addition rule. This is used for the probability of something or something else happening. And you find it by adding up the probabilities that each of these happens. But then you have to subtract out what happens, what can happen both times. The reason that happens is you often will have, if you have something, probability of A and B, that is going to help you subtract out any sort of repeats. If you don't believe me, go back, retry question C, and this time I want you to try it by plugging in the formula. And you will find that you do end up getting the same answer that we just got. So that's something for you to try on your own if you don't believe me on this one. For our last example, it's about owning a landline or a cell phone. So go ahead and read through it. They tell us 60% of U.S. households have a landline 89% have cell phones, and 51% have both. You might notice that these percentages, no matter how you add them up, they do not add up to 100. So that means that we might have to do some extra interesting stuff here. So I actually think it's always a nice idea for this type of problem to use a Venn diagram so that you can visualize it. So I'll go ahead and draw this out. And I'm going to have two circles. The one on the left I'm going to use for having a landline. The one on the right is going to be for having a cell phone. Anything outside of these two circles is going to be having neither. So let's go ahead and see if we can figure out how to do this. The first thing that they tell you is that 51% had both. We're going to use that to help us get started. So the both is going to go in the very middle. The 51% will be right there. It's 0.51. To fill in the next part, let's fill in the landline next. This part right here, this area right here, that does not include the 0.51 is going to be people who only have a landline. You can find that by taking the total number of people with a landline, which is 60%, and subtracting 0.51 from that. When you do that, you get that there are 0.09. So that means 9% of people have a landline but no cell phone. Similarly, we can do the same thing for cell phones. If you want to find this part right here, this is going to give you the people that have a cell phone but no landline. You find that by doing 0.89 minus the people that have both. And when you do that, you end up getting 0.38. So the last thing that you need to do is you need to figure out how many are left over. So you can figure that out. The people that have either of them, these three numbers in like the 0.09 plus 0.51 plus 0.38, these are going to all add up to 0.98. So in order to find out, that's telling us that 98% of people have either of those two, which actually is going to give us the answer for B. I'll get to that in a second. So that's telling us that 98% have either one of those. So that means that there's 2% left over. Those are going to be the ones that don't have a landline or a cell phone. So let's go to part B, and I'm actually going to do part B. I did actually just kind of do it right here. It's the 0.98, but I'm going to do it using the formula. So we're looking for the probability that a household has at least one of the two types of phones. So having a landline or a cell phone. You'll find that if you try to add all the probabilities up, you do get something weird that is over 100%. We don't want that. So in this case, you have to do the probability of a landline plus the probability of a cell phone minus the probability that they have both. That will help us get rid of any repeats. So that'll get, otherwise, if we don't do that, that means that will give us something where we're counting people that have a landline and cell phone twice. So we don't want that to happen. So the probability of having a landline is 0.6. Probability of a cell phone is 0.89. Probability of both is 0.51. You will find that this ends up giving us 0.98. It actually is the same answer that we had in the previous thing. It was just kind of a different way of doing it. So as you do more of these problems, you'll find different ways to do them, so you can just figure out which works best for you. The thing I love about the Venn diagram is that all questions after you draw the diagram are very easy. So they ask you the probability that a household has a cell phone only. That's going to be this 0.38 right here. And that's our answer for that one.